Hello everyone, this is Sir Saeed. Hope you are doing well. Today I'm going to start some concepts of internal resistance. Actually, internal resistance is the resistance offered by the battery, cell, or you can say some other source. And the internal resistor have some voltage dissipation against it. So if we have the sum of all the potentials, like the potential against the internal resistor and the potential against the external resistor, the sum of all these potential is always equal to EMF. So EMF remains constant. For example, just going to start from a diagram. Look at here. If we have mm, a power supply, or you can say cell, and the external resistor is attached with it. This is enclosed because the internal resistor is the part of the battery or cell, small r, and its EMF is E, external resistor is R. The current flowing is I. Now, look at this circuit. Here, internal and external resistors are in series, they are not in parallel, because the current has just one path to flow, or you can say the similar current is going to flow from small r, then from capital R, and ended at this negative terminal of the cell. So we may write it as E is equal to I, and the resistors are always added because they are in series. So E is equal to IR plus IR. This small r into I is the voltage against the internal resistor, and capital I into R is the voltage against external resistor. This is also called terminal voltage or terminal potential difference. So you may write it as IR plus V, and if we write V as a subject, then it is equal to E minus IR. Here, this E is always constant. So, if we check the relationship by using a graph, then the graph is like we have current here on x-axis and the voltage here on y-axis. So, this voltage is on y-axis while this current is on x-axis. Then if we write it in terms of the straight line equation, then this is called M and C. Now this is y is equal to mx plus c. By the comparison, we can see that m is gradient, which is equal to r, means the internal resistance, and the y-intercept is always equal to the EMF. So generally we have a line like this one, and if we extend this graph, then it will meet at this point. This point is EMF, which remains constant, and if we extend on the other side, this is the current. Now if you want to get the EMF, then you can find the value from the graph, and if you want to find the internal resistance, then find the gradient of this graph. The gradient M of this graph will give you the internal resistance. So look at this graph again. On this graph here, the value of I is 0, means no current is flowing through the circuit. Then the EMF and the voltage are similar. The EMF is the maximum voltage, means if you have a cell here like this one with the two terminals like this one, and straight away you attach a voltmeter with it, then this voltmeter will give you the EMF of this cell because no current is flowing through it. But if you have this cell here, and this cell is attached with some resistor like this one, and now you have a voltmeter here parallel with the terminals. Now this voltmeter will give you the potential difference or the voltage. Hopefully you are getting the concept. Now, on the next slide, if you have V is equal to E minus IR, then this E is always constant. And if we have again a cell attached with the internal resistor, actually I'm selecting some topics from which the students have a lot of questions. So to make some concepts, uh, okay, this is the variable external resistor. Suppose the resistance of this resistor is increasing. This is a variable resistor. We increase the resistance. When the resistance increases, the overall resistance of the circuit increases and the current decreases, means the current falls. When the current falls, this whole factor decreases. So a small value will subtract from EMF and hence this voltage increases. So the terminal potential difference increases. And if we have the decrease in the resistance, then there is an increase in the current and this value is decreases and hence the terminal potential difference falls. And a similar concept is used while solving the past paper questions. And thank you very much. Good luck.